Okay, so on to homework number 4, inductive versus deductive reasoning. So the thing I like to keep in mind would be this picture. Um, so inductive versus deductive, it really depends upon where your argument starts and where it stops. So if your reasoning or your argument starts with something general and ends with a specific statement, that is a deductive way of reasoning. Whereas if you start with specific things and then you end with a generalization, that would be inductive reasoning. So general statements, red flags would be the words all or every, all and every. I mean, that's painting with a broad brush. So general statements are very, very broad statements. Hence, the words all and every show up with general statements. Specific statements are exactly that. They're very individualized or very, very concrete and very rigid. So let's take a look at this. This is from homework 4. The Flanagans are having their 5th child. All of their children are mathematically gifted, so the youngest child is bound to be mathematically gifted as well. So this first sentence is more so, I mean, that is saying something specific, but that's not where you are reasoning. The reasoning is this last sentence. So notice this last sentence, all of their children are mathematically gifted. All. That is a keyword for a general statement. So you're starting with a general statement, all of their children are mathematically gifted, and then you're ending with something specific, so the youngest child is bound to be mathematically gifted as well. That's a very specific statement. So we're starting general, we're ending specific, so that would be deductive reasoning. So this is deductive because the premise is general and the conclusion is specific. Absolutely. All right. All right, let's try one of those. All right. Maybe. Okay. So, I guess let's go back and look at this one. This is a little. You can get wrapped up in your own thoughts. So, every coach must know his sport well. That is a very general statement, right? The word every sitting there says that's a general statement. However, the question is, does the reasoning begin there? So every coach must know his sport well. Marty Wright is a baseball coach. So Marty Wright knows baseball well. Similarly, this could read, every coach must know his sport well. So Marty Wright, a baseball coach, knows baseball well. So recognize you are starting general and you're ending specific. So that would be general to specific. So that would be your deductive style reasoning. So just a red flag for some of these. The way they phrase them can be a little tricky, but at the end of the day, you have a 50-50 shot. And the thing you want to compartmentalize is starting specific, ending general, inductive. Starting general and ending specific is deductive. So let's try that on for this next question. I've never found mail in my mailbox on a Sunday. Okay. That's pretty specific. I've never found mail in my mailbox on a Sunday. That's a specific statement, or Saturday rather. The Postal Service must not have Saturday deliveries. That would be a generalized statement because you started with something very specific. You started with particular instances, events, and you use those particular instances and events to induce a generalization about the Postal Service. So you start specific and you end general, which is inductive. All argument is inductive because the premise is specific and the conclusion is general. Absolutely. Again, conclusion is where you end, and the premise is where you start. And really, this diagram is the key to answering all of these questions. So, summer months are windier than spring months. Is that general or specific? Well, that's a general statement. Summer months are windier than spring months. The wind must blow more often in June than in April. So you started with a general statement, you ended with a specific statement, so it would be a deductive style reasoning. And I feel like most of these go off those types of lines of thought. Flanagan's again. Flanagan's having more kids. All right, here we go. Determine the truth of the premises of the following argument. Then assess the strength of the argument and discuss the truth of the conclusion. So 3 plus 7 is 10, 5 plus 3 is 8, 9 plus 5 is 14. Conclusion. The sum of an odd integer and an odd integer is an even integer. Okay. So, which of the following are true statements? Select all that apply. Well, all of these premises, 5, 3 is 8, 9, 5, 14, 3, 7, 10, those are all true. So the first, second, and third premise are all true. Assess the strength of the argument and discuss the truth of the conclusion. So the argument is very weak, the conclusion is false. The conclusion is certainly true. The argument is moderately strong, the conclusion is false. No, the argument is moderately strong, the conclusion is true. Absolutely. So the giveaway here was the fact that the conclusion was true. For this strong and weak, I will refer you to the lecture notes, or your book even, to see what constitutes as a weak argument or a strong argument. Similar song and dance. Similar. All right, here's something a little different. However, I will let you try this one on for size. It follows the same lines of thought as before, but instead of adding odd numbers, we are multiplying negatives. Okay. For all real numbers, a and b, a plus b equals b plus a. Okay. What values of a and b, if any, yield a counterexample? So a counterexample is an example that illustrates the original premise to be false. So that would be, we want to find values for a and b so that when we add a plus b, it does not equal b plus a. So you want to find values of a and b so that when you add them together one way, it doesn't equal when you add them together the other way. Well, from basic addition, it doesn't matter if you go a plus b or b plus a. You get the same result. So there is no counterexample. You can run through all these options, add them together one way, add them together the other way, and you'll see that 1 plus 0 is the same as 0 plus 1. Similarly, 8 plus 5 is the same as 5 plus 8, or negative 2 plus negative 3 is the same as negative 3 plus negative 2. So there is no counterexample. Is the rule true? Yes. All right. Okay. So premise, if a natural number is divisible by 20, then it is divisible by 10. Well, yeah, absolutely, because 20 is divisible by 10. If a natural number is divisible by 10, then it is divisible by 5. Yeah. If a natural number is divisible by 20, then it is divisible by 5. Sure, yeah, and that follows from, so that's the conclusion, and notice how that conclusion manifested from these two premises. If it's divisible by 20, then divisible by 10. If divisible by 10, then divisible by 5. So, through transitivity, 20, if it's divisible by 20, then it's divisible by 5. Is the entire argument valid? Yes. Because there is a clear chain from a natural number is divisible by 20 to a natural number is divisible by 5. So it's either B or D, where D says yes because both of the premises are true. So for a valid argument, there has to be a natural reaction between your premises that arrive at the conclusion. So recognize that part D, yes, because both premises are true. Yes, that is true. And because both premises are true, both premises are true. So part D is quasi-correct. However, for the argument to be valid, to have a valid argument, the premises need to logically follow one another, which clearly they do, right? 20, if it's divisible by 20, then divisible by 10. If divisible by 10, then divisible by 5. There's a series of events that support this conclusion. So D is also correct, but you can dig a little deeper, I guess is a way of saying it. Again, more of the same on this one. So that concludes inductive versus deductive reasoning. Keep in mind, this picture is really what you're going to want to compartmentalize. All right, thanks for listening. Send me an email if you have questions.